Well, good afternoon, everybody, and welcome to another one of our weekly seminars for TESS, which is the Center for Tropical Environmental and Sustainability Science here at JCU. One of the most active centers or groups that's focusing primarily on terrestrial issues, not so much the marine side of things, but on the land. So forests, people, cities, villages, ecosystems, all that type of thing on land is what we tend to focus on mostly. It's an absolute pleasure to introduce David Edwards here from the University of Cambridge. We know David really well because he spent 2 or 3 years here in Cairns as a postdoc in my lab, and was lots of fun and very, very productive while he was here. Just try to hit a few of David's highlights in his career. He did his PhD at East Anglia, University of East Anglia in the UK, and a very strong program there led by, I guess, Carlos Perez. David, were you working with Carlos Perez?
Well, I'm Doug.
Yeah, okay. And anyway, he's then had postdocs at Princeton, at Leeds, here. He then, when he was in my lab here for 2 or 3 years, he was just getting ready to apply for a permanent job, and he got an offer for a lifetime professorship, tenured professorship at Yale, and he turned it down. And I couldn't believe it. I was practically shaking him by his lapels, going, "You don't turn down Yale." Anyway, so he did, and he went to Sheffield, which is a very fine university in the UK, and then now, of course, he's at Cambridge. So he's done just fine on his own without listening to any of my career advice. It's a pleasure to have David. Oh, David, I think your other screen just needs to be maximized now, if you could do. And anyway, because otherwise I'm not going to know the title of this talk, but I'm sure it'll be a very interesting talk about the Anthropocene, and with a pleasure to have David Edwards. Thank you. David, also, there'll be about another 20 people watching online. So we do get a little bit of an audience here, 50 or so.
Awesome. Well, thanks so much, Bill, for kind introduction. Awesome to be able to talk to you guys again. I looked back at my old talks and realized the last one I gave was in 2012 in Cairns. So a real pleasure to be able to talk to some of the old faces and some new. So we're going to think about tropical forests and biodiversity conservation in the Anthropocene. And of course, tropical forests, like this primary forest, these have undisputed values for conservation. They are the true global powerhouses of terrestrial biodiversity, and they harbour a whole suite of enigmatic flora and fauna. But those forests, those primary forests, they're at risk. And the first key risk for that is from selective logging. And what we're talking about here is the selective harvest of just these really large marketable trees and leaving everything else behind in the matrix. So that tree's being cut down there. We saw it being cut down. Here it is on the ground. You can see that lots of other components of the forest remain intact despite that harvest. So you're leaving behind lots of smaller individuals, less desirable species, but a damaged forest structure remains. So most tropical forests either have been or they will eventually be selectively logged. And yet those forests have often been kind of written off in the concepts of conservation. Norway, for example, agreed to pay Indonesia $1 billion to save forests, and Indonesia used it, perhaps naturally, to conserve primary forests and deep peatlands, both really important environments, undeniably. But they ignored 35 million hectares of logged over forests, which continue to be slated for conversion. So that is a problem, giving you the answer already, because of this rampant tropical deforestation. After that logging, often we see deforestation, and we've lost around 220 million hectares of tropical moist forests, nearly 20% of cover in this 30-year window, which is a truly horrifying statistic. And what we're losing it for tends to be these kind of large-scale agriculture, cattle farming, and plantation agriculture. So how do we conserve tropical forests, and how do we protect the biodiversity therein? And that's the key driving question of all the research that we've been doing over the last 15 plus years. So we can break that down for this talk into a couple of key components. How does logging impact biodiversity? think about that first, thinking about using rigorous ecological field study, and then how we might improve protection of those forests and biodiversity, thinking more in context of different kinds of policy frameworks, how we might adopt cross-disciplinary techniques to help us in our goals. So let's think about that first question. And in many ways, this is where I kind of left off at JCU. So I thought it'd be nice to kind of start out here as well. So what's the effect of logging on biodiversity? We can answer that, and we have in my group answered that with many taxa, but I'm just going to briefly present some work we did on trees and vines by Ainhoa McGratch and Bill. And what we can find at local scale, you go to a plot here and you go to a plot there in primary and in unlogged forest, primary forest and in logged forest. And when you do that and you build up the number of small scale plots, you find that in the context of trees on the right, there's the similar species richness in the logged forest triangles as there are in the primary forest circles. And in fact, in vines, group that does well with all the light created, you can find even a larger species richness. So we tend to find at these small spatial scales that logged forests retain biodiversity. But in this article we put together for tree about 10 years ago now, we started to think about how we might look at beta diversity, the turnover of species across space, and how that might inform our understanding of biodiversity conservation problems. And in particular, we brought this kind of theoretical framework to bear. So if we think about our pristine habitat at the top, we have some kind of anthropogenic disturbance, then there's two key kind of directions that things can take. We can heterogenize our environment, we can increase the turnover of species with space, or we might homogenize it. We reduce that turnover of biodiversity across space. Now, in the context of logging large canopy trees, if we focus on those trees themselves, we are removing species, removing woods. So we are getting rid of the potential that we add in species to heterogenize or homogenize, and we are taking species out. And so we might find, actually, if we remove a fairly common species and leave behind rarer species, we might actually increase the turnover of species and increase beta diversity. Or if we're taking out perhaps the rarer species, then we may lower our beta diversity relative to a primary forest. If logging does either of these two things, it still represents a rewiring of what are pristine forest community structuring across space, the very driving forces of tropical hyperdiversity. So we wanted to think about this question: how does logging of canopy trees impact beta diversity? My PhD student Chris Bousfield did this, focusing on the Brazilian Amazon. So we were afforded some wonderful data from a large concession. They measured and identified 155,000 adult trees, over 3,000 hectares of forest. So we've now got the kind of resolution of data that's simply not been possible to use before. And using those data, we then generate a simulation process. We use price data to allow us to harvest the more valuable stems. We account for the residual damage we know that occurs in logging. So this is what we find. We find as on our x-axis here, we've got logging intensity. On our y, we've got partial ecological distance. And if we start out at 0, that represents the beta diversity, the turnover across space in a pristine forest. As we log the forest, the very large trees in green, we now see that we have a much changed beta diversity. We are increasing the beta diversity as we log the forest. And for large trees as well, at higher intensities, we also find that to be the case. So we've taken trees out. This is evidence that we are subtractively heterogenizing, increasing the diversity of across space through a beta diversity lens. So there are clear negatives then of these findings. We've got a process in which we are generating heterogenization of the spatial patterning of trees. And we are therefore breaking down these kind of broad scale compositional patterns that we might expect. What's the consequences of that for recruitment of those trees, for fauna reliant upon emergent trees? That still remains something of an open question. But there are also real positives of the data that I've shown here and I've alluded to. We've got high alpha diversity, those local scale findings for trees and lianas and for lots and lots of other taxa. Those high diversities are remaining, albeit perhaps with different species. And we've got low impacts on beta diversity in medium trees and in the low in logging intensities for large trees. So there is retention of substantial conservation value in these log forests. And then I would argue protecting them must be a priority. And that, of course, is because of this deforestation risk of these log forests. So we've been focusing on the impacts of deforestation for quite some time. And I've been trying to do that increasingly, again, through the lens of impacts across scales. So this is Edix Pará, my postdoc, and we've been focusing on this large landscape in Colombia. This is spanning about 300 kilometers, maybe more, 400 kilometers from north to south, ranging from 1,000 to nearly 4,000 meters above sea level. And we've sampled coming up to 400 points, and we've been looking at orchids in those points. So our data set, quite large, we've got 340 species of orchid. We've got 11 new species of orchid to science that we're describing in that data. And we can find three key problems with the loss of tropical forest for deforestation. So the first, it can be illustrated through the size of these dots. The green dots represent natural habitat, the brown, the pasture. And the green dots are much bigger. They represent far higher abundance of orchids in our sampling plots in natural habitat than pasture. The second is that the y-axis, the species richness, those dots for greens are very much higher. We have many more species of orchid in a forest environment than once we've converted it to a pasture. The third key take home can be revealed more effectively through a statistical model, which I'll break down to this. So we're now interested in this y-axis, x-axis, of elevation. And there's a classic biogeographic pattern in orchids of a hump-shaped diversity relationship. Roughly 2,500 meters is the global epicenter of orchid diversity. So we see that hump shape there, and we find that when we convert forests across that elevational gradient, we are entirely rewiring that enduring biogeographic pattern. We've now got a flat relationship in diversity with elevation. This also tells us then that deforestation at mid-elevations, in this context, in this particular group and place, will represent the biggest cost to diversity relative to other altitudes. Now, that was alpha scale. We broaden this out to the entire data set. We had nearly 300 species of orchid in natural habitat. There were just 52 species occurring in the pasture. So it's a massive gamma scale loss of diversity. Now, a big question that we've been working on and others is whether you can make farmland more friendly for wildlife. And I don't really want to go into that, but however you manage it, I think it's fair to say that you're going to have lower biological value in farmland than a forest. Okay, so we must protect our logged and degraded forests. And there are some kind of key questions that I think still remain. The first is how we might balance the environmental and socioeconomic outcomes of restoring logged over forests. And to get at that, my PhD students, Patrick Cannon and Catherine Finlayson, put together this replicated liana experiment, cutting experiment in Borneo, where they cut away all of those lianas we saw earlier, becoming very, very abundant in log forests. They've been working on total cuts, which is what normally happens to restore the forest, versus lower intensity cuts, things like 80 or 60%, relative to an uncut control. Now, unfortunately, the pandemic's got in the way, and they set this experiment up before the pandemic, and we've only just been able to return with the road being rebuilt, etc. So I can't tell you what we've found from that. This is Giovanni Perez. He's thinking about how logging and deforestation impact phylogenetic and functional diversity across spatial scales, using some of those data sets we've created in Colombia. And then lastly, I want to understand how fire is going to interact with timber production under increasingly severe climate change. And we've just started to do some work on that I'd like to talk about briefly. So this is Chris Bousfield again. His last PhD chapter is what I'm presenting, and he's now my postdoc carrying some of this work on. So we're thinking about severe fire and then how that impacts timber loss. And what Chris did is he took a couple of major layers globally of timber lands. This is the Curtis layer, and then we have the Lessif layer. And taking these two layers of timber production, he was able to cross them with this really nice work. So these layers are including timber plantations. These are clear-cut or low diversity northern hemisphere systems. What they tend not to be is selective logging based. So you can then take these two global understandings of where we're producing timber, and you can cross them with this really nice layer by Tjukovina, which looks at all deforestation between 2000 and 2021, and then asks whether that was driven by some other force, agriculture, or whether it was driven by fire, so severe changing fires. So when he crosses those layers, he finds that we've suffered significant timber losses in the 21st century. Lessif highlights Northwest North America, the Northeast Russia there, Australia and Brazil, and using the Curtis layer, again, pretty much the same hotspots, although Brazil is a little bit less obvious. We're talking about somewhere between 19 and 25 million hectares of timber producing lands that have been deforested through severe wildfire. So if we look at that by aggregating all of those dots, we can start thinking about this at national level. And we see that in total area burned, it's the northern nations that are dominating. Russia, some 3 to 6.5 million hectares lost. USA, around 4 million hectares. And Canada, 4 million hectares. Just to say, this is up to 2021. We've missed the 10-ish million hectares that will have been lost in Canada last year. If we think about this as a proportion, though, which is at a national timber production level extremely important, of course, Portugal's lost 12 to 14%. Again, that's missing those massive fires from last year. And Australia, you guys have lost 6 to 10%. And again, you continue to lose more of your timber producing lands through fire. And it's not just that we've lost a lot. We've also seen that the rate of loss is increasing. So relative to the 2000 to 2015 baseline, the 2016 to 2021 saw a 2 to 4-fold increase in area burned. And I would suggest, given what we've seen in the last couple of years, that relationship will carry on going up. And this is something that's occurring over most of the continents, North America, Latin America, Australasia. They're having these increases to some degree in Africa, but Africa is not really a major timber producer. And Eurasia, for whatever reason, has not really seen an actual increase. All right, so there are major hotspots of timber loss globally through fire, and we can see that's increasing. We're talking about having lost an area the size of Great Britain. That's $50 to $70 billion worth of timber that's gone. So this is kind of the jumping off point. It's not very tropical. It's the jumping off point because I think there are some important implications. I mean, the first question still is that was looking in the rear view mirror, is to think about how climate change is going to impact timber production longer term. And Chris has been developing some nice models to answer that already. From that point, we need to understand whether any lost production under climate change is going to result in changed price structures and then increase the pressure that you may find on tropical forests. And we're working with some global equilibrium modelers to start trying to unpick that. And then we want to find out whether that production of timber within tropical forests may itself increase fire risk. So does selective logging increase the potential of major burns within tropical forests? All right, so now I'm going to move on to think about how we might improve protection of tropical forests and of biodiversity therein. And there are, of course, lots and lots of different ways that we might help to more effectively conserve forests. I don't have time to talk about all of them, but I've picked three that I think are particularly pertinent. I think we can improve the detection of illegal activity in tropical forests. I think we need to better manage wildlife trade and can do that. And I think we need to be thinking about how we can empower local communities to protect their lands. So let's think about detection of logging first. This is my former PhD student. He now works with the Canadian Forest Department, looking for fires, actually. So a major research problem has been to detect selective logging using remote sensing. On the right here, this is a contiguous landscape. On the right, we have an area in which you can see in pink lots of deforestation. And for the last 30 odd years or 20 odd years, we've become really, really good at using remote sensed imagery to detect deforestation. On the left is a selectively logged piece of forest. And it is basically impossible to detect that with the eye, and it has been an enduring problem how to detect that with satellite imagery. So what we did is we took detailed Amazonian logging records, the kind of records that I showed in the beta diversity work, and these provide us with precise felling locations and times for tens of thousands of trees. So what Matt did is he took the freely available Landsat imagery and then did some random forest machine learning algorithm development, in which he took 75% of all of our cutting records as training data and then was able to do some validation. So this is what he finds. The headline finding is that using his algorithms, he can detect 90% of logged pixels with 20% commission, 8% omission errors, and that's pretty good for remote sensing. So this is the Jamari concession in Rondônia in southwest Brazil, and this is the UPA that they logged in 2011. You can see his algorithms picked that up. Got a scan line problem here. We can see in 2012, done a good job for 13, 14, and to some degree for 15. So that's great. Matt has achieved here something that people have not been able to do before, and that's awesome. But I think it's really important, as much as possible, to not only be able to crack important scientific challenges, but to then ask how we can put these challenges, put these new approaches in the hands of people who might be able to meaningfully use them. So can these kinds of algorithms be used by policymakers? So what we started to do was work with Lucetti Vega here. She's the director of OSINFOR, Peru's forest oversight agency, to work with her to see whether her team would be able to use these algorithms to detect illegal selective logging in the Peruvian Amazon. So since 2020, we've trained over 100 of OSINFOR staff to use these algorithms. We've developed user-friendly apps, which are now embedded within the OSINFOR website. And OSINT4 have begun implementing those algorithms. This is a slide from a talk Lucetti gave last year, in which she's telling us that, that they've monitored 155,000 hectares of their Amazonian logging concessions, and through the use of that, they've been able to detect the illegal logging of over 300 kilometers put end to end in a line of timber boards. And since then, they've had their first successful prosecution of these illegal logging enterprises. So we can help improve detection and therefore potential for penalizing illegal operators. I'd like to think about how we might better manage the wildlife trade. So the first key question, if you want to better manage the wildlife trade as I see it, is to understand how extensive the trade is in the first place. And that was actually a key unknown when I first started to think that beyond just timber, we needed to think about trade in species. So what we set about doing was taking all the information we could find in the IUCN website about species use, as well as combining that with CITES to assess whether or which of 31,000 terrestrial vertebrate species are known to be traded or to have recently been traded. So we published this article in Science back in, I think, 2019, in which we then brought these findings together. So the headline finding is that a quarter of all terrestrial vertebrate species are known to be traded through those IUCN and CITES directions. That ranges from, at the low end, 10 to 14% of amphibians and reptiles, all the way up to around 45% of birds. We're able to then plot the species that are being traded on their phylogenies to find two key things. Firstly, if you look at either of these phylogenies, you'll see that the red percentage of the clade being traded really spans around that phylogenetic tree. So we really are pretty much trading things from right around the entire phylogenies. But you can also see that there's some really strong areas of red, and that's telling us that there's some phylogenetic conservedness in trade. So key groups like the Citicidae, the parrots, Strigidae, the owls, for example, for birds, and mustelids and the bovids in mammals, for example, are being traded. Okay, so we now realize that we've got about a quarter of terrestrial vertebrates in trade. It's targeting specific clades. In some instances, it was basically 100% of species within a clade are in trade. So there's the real potential for a conservation problem here. So the next thing we might want to do is to understand where the hotspots of diversity in trade are. And we, within that article, we followed that through. We brought in the IUCN range maps for all of our traded species and overlaid them, and can then think about where hotspots of richness in trade are. And you can see this is just for birds, that it's largely these tropical zones. The Andes, the East African zone, quite a bit of Southeast Asia. Now, if we take that bottom map, the yellows, 25% and 5% hotspot map, and we overlay them for the 4 taxonomic groups, we get something like this. So we can now see, again, that in both instances, it's those tropical regions which are seeing the lion's share of species coming into trade. They really are the big powerhouses, not only of terrestrial diversity, but of things moving into trade. Last year, we then moved beyond just thinking about this problem through the lens of species richness and started thinking about other components of diversity. And here I'm just going to present the functional diversity figures. We can see a similar pattern. The key areas of our trade in unique functions is going on in the tropics. Okay, so the tropics represent the hotspots of species richness, functional diversity, and you'll take my word for it, phylogenetic diversity in trade. So we know there's a lot of species in trade. We know there are many tropical, but what we then really need to know is how trade is actually impacting the abundance of species. Maybe trade is very, very sustainable, a few individuals are taken, and there's no impact on populations. So my PhD student, Oscar Morton, started to think about this problem, and he did a global meta-analysis in which he went out and found all of the studies on that had paired traded and untraded sampling sites. So they were looking at the abundance of a particular species within a traded and an untraded location. This yielded in the end just over 500 species level effect sizes from 31 studies. So this is what he finds. Our x-axis here is the log response ratio. The dashed black line is 0. If you move to the left of that line, you are having a negative consequence on abundance in the traded area relative to the untraded area. And the red line represents the median. That represents a 62% decline in abundance where species are traded. At the top left, there's this solid black line. Those are the 15% of species that were so heavily trapped that they were in fact extirpated locally, and they had a 100% decline. So it's a pretty difficult picture, that, and it becomes even more difficult when we look at the effects through the lens of IUCN status. And we can see that the least concern in green there, the species of minimal conservation problem, they are not really being affected by trade, but it's the vulnerable, endangered and critically endangered species that are tending to have substantial negative impacts of trade upon their abundance. Now, one of the key findings, as I see it from this article, was actually not something we could graph, and that's illustrated here. This is a severe threat to global wildlife trade, and yet all Oscar could find was 31 studies. A quarter of the world's terrestrial biodiversity is being traded, and you could only find 31 studies on it with treatment versus control comparisons. There were no studies on amphibians. There were only 4, I think, on reptiles. There was nothing on invertebrates, no cacti, no orchids. So we're doing very poorly here as a collective. And I think really we need to kind of step up and start to put some significant focus on how we are trading species and what the impacts of that are on their wild populations. Okay, so there are massive reductions in abundance, even extirpations, but there are massive knowledge gaps. So the last question that I think we can then think about in this part of the talk is the potential role of CITES in preventing losses. So that's the Convention on International Trade of Endangered Species. That won't capture anything traded nationally, locally. So CITES, its founding mandate is to protect wild fauna and flora against over-exploitation through international trade. And the key way that CITES does that is by allowing parties to export endangered species after they have developed a positive non-detriment finding. The problem is that despite there being millions of trades of hundreds of millions of individuals, non-detriment findings are not publicly available. They're not publicly scrutable. So Oscar then, for another part of his PhD, started to try to work out how we might tackle this question as to whether quotas are actually sustainable. So what he did is he looked at changes over time in the amount of trade going on through CITES and matched them to changes in the IUCN status of species being traded. And species being traded, we've got 4 groups: birds, mammals, reptiles, amphibians. And species being traded, fall into 4 different classes in the bottom here. And what we're interested in, the blue dots, they became not threatened. And in particular, the red dots, these became threatened over time. And then we're monitoring how they their abundances, if you will, in CITES trade. And as you can see, the vast majority of these dots, whatever their color, sit bang on the 0 line. In other words, the trade was going on in CITES, a change happened in IUCN status, and the amount being traded through CITES did not change at all. And they're particularly a concern is the fact there are lots of red dots here. There are lots of species that are becoming at risk of global extinction, and or they are staying in a threatened category, but perhaps a worse category, and they're simply being traded through CITES at the same volumes. And of course, at the bottom there, for example, in frogs, there are several species that not only became threatened, but they actually had their volumes after becoming threatened increasing in CITES through time. So we can't answer that question, are they sustainable as we would like? We'd need the non-detriment findings, but certainly the way we've gone about this suggests that there is a disconnect between increasing extinction threat and the amount of trade volume going on. And that would suggest that maybe these are not sustainable on occasions. Now, we're just starting to think about this in the context of rare timbers traded through CITES. I don't have all the findings, but we can see that there are some worrying trends already in our data. This is African teak, IUCN endangered, and we can see over time the quantity of this species being traded is going up substantially. It's 3 times more now than it was back in 2000. This is a highly threatened species. So if you're trading highly threatened species, we really have to have confidence that this is a sustainable trade. And I don't think the evidence is there at the moment that CITES is definitely preventing over-exploitation. So that leads us to 2 key questions. First, or 2 key things. Firstly, really have to move. CITES was created in the late 1970s, early 80s. It is not fit for a modern day world. It was never developed in an interconnected global world of internet traffic, etc. We need these non-detriment findings to be publicly available, publicly scrutable, and ideally that the public and experts can comment on whether a particular NDF is bringing all the right evidence together to enable a particular trade through CITES. And I think academically we can help too. We can develop trait-based and phylogenetic-based approaches to help us identify what a sustainable offtake might look like for a particular species, given what we know from other traded species. And we have to help nations that don't have the capacity to produce NDFs of the quality we'd really like to see. We have to be there to scientifically help them inform them. Okay, so I'm going to finish up by briefly thinking about how we may empower local, or whether we should like to empower local communities to deliver tropical forest goals. So we're thinking about indigenous protection of forests. There are 2 million kilometers squared of protected areas in tropical forests. That's awesome. But there are 3.4 million kilometers squared of indigenous lands in tropical forests, and 1.7 million kilometers squared of indigenous lands that then overlap with PAs. Now, previous work has focused on this, the question as to whether indigenous protection helps reduce deforestation in Latin America, and they've suggested that that is indeed the case. But what we don't know is whether indigenous lands can reduce deforestation at a pan-tropical scale, Central America and all the rest of the tropics. And also, we have no understanding as to whether indigenous lands reduce degradation, things like selective logging. So my PhD student, Jocelyn C., set about asking whether indigenous lands reduce deforestation and degradation in tropical moist forests. What she did was do some statistical matching of non-protected sites with indigenous lands, protected areas, and these protected indigenous areas. And what that matching has done is it's kind of controlled out a lot of socioeconomic and biophysical underlying conditions that might affect our comparisons. And she uses this wonderful data from Van Kootsum, which looks at deforestation and degradation as separate drivers. And we're focusing on the 2010 to 2019 component of that data. So this is what Jocelyn finds. We'll focus in the top left here on Africa. We're looking at deforestation. We've got on the y-axis proportion of forest, and we have a green bar across there. That's the amount of deforestation that occurred in that time frame without any protection. And then we have 3 bars. The black bar is protected areas. So protected areas in Africa were pretty much losing as much forest as areas that had no protection. Now, we're interested mainly in the orange bar. This is our indigenous areas. And we're seeing that relative to both non-protection or PAs, they are having lower levels of deforestation. And that pattern, it follows in the Americas and the Asia Pacific. Indigenous lands are performing roughly as well as protected areas in reducing deforestation relative to non-protection. And it also follows when we think about degradation, these logging, fire and driving processes. So indigenous lands are performing better than no protection and roughly the same as protected areas. So that's awesome. They reduce deforestation and degradation, and they're broadly performing similar to areas that have received some kind of state level or regional level protection oversight. So we clearly need to actively support indigenous communities in protection of forests. We have to be thinking about how to strengthen indigenous people's rights, and certainly the Kunming Montreal Agreement is pushing in that direction. And I think making sure we're providing secure land tenure is one key way of doing that. Now, the last thing we can then think about is whether, from a forest cover perspective, a climate change perspective, this is awesome, but whether indigenous lands might also protect biodiversity. And that's something we've just started to touch on. Jocelyn, for her last PhD chapter, produced this nice paper. What we can see here is amphibians, birds, mammals, and reptiles, 4 different taxonomic groups as we go down. And the shade of blue represents the amount of a particular species range that is covered by indigenous lands. And we can see that for all of those 4 taxonomic groups, whether they're threatened, near threatened, least concern, or data deficient, there is a non-trivial amount of species with this very dark blue. In other words, that their entire global range is only within indigenous lands. And then we've got quite a lot more species with these darker blues. They've got, say, 60+% of their global range occurring only in indigenous lands. So that would point to these being very, very important places as well from a biodiversity conservation perspective. Okay, so to finish, how do we, what have we learned about conserving tropical forests? Well, firstly, logging, it's harmful to biodiversity. It's going on everywhere. But those forests, they retain a lot of diversity, and we need to have a focus then on protecting them from conversion and ideally on also enhancing their values, perhaps through restoration. But we need to exploit policy mechanisms better. We need to be able to improve those outcomes from logging and prevent that illegal logging. We need to be preventing wildlife over-exploitation, both nationally and in particular, I think we have a responsibility to do so internationally, and to help us help work with indigenous communities to enhance protection networks. With that, I must thank all these people without whom we never would have achieved the work, our funders and our great collaborators at the Instituto Alexander von Humboldt. And thank you very much for the invite and for listening, and I'm delighted to take any questions. Thank you. Hello. Oh, I hope this isn't going wrong.
We're going to still hear you, David.
Oh, good. I was like, oh my God, what if the internet's crashed?
I'm not sure about the room, but I'm remote as well. That was great. Thank you. I don't know where the
Pleasure.
computer is.
Hi, David. It's Penny Van Oosterzee here. Nice to see you there. Can you hear me?
Hiya, Penny.
Look, I thought I'd ask a question. I don't know whether the others can hear it. It was more to do with policy and scientific research and how we can create policy questions. I'm not sure that many scientists actually think about that when they're doing research. They publish papers and then either sit back and go on to another topic or sit back and feel that that was done. Just one, and clearly what your unit's doing is thinking about the bigger picture and how it can convert into policy. And I just wondered whether that's a bigger question. And I thought that perhaps we should actually all be looking a bit more at policy.
So I would agree. And I don't think, I think first of all, though, in defense of science not necessarily for science sake, actually, we do need to push the boundaries of understanding. And sometimes you need to set the groundwork, if that makes sense, to kind of to develop a new technique or a new way of looking at things. And at that point, you can then start to engage policymakers and say, hey, look, we've found this. What lead-on questions do you have? Well, you build a reputation in something that they then can kind of hold on to and then start being confident to ask questions of you. It's not easy, of course. The questions that policymakers might want to know the answers to are often not questions that will get published in Nature or Science, and they are often questions to which they would like the answer yesterday. And so, yes, I think as scientists, we have a duty wherever possible to engage with policymakers, but equally, I don't think we should be abandoning our academic freedoms to answer questions that we think are important and that may be important, in the future, or to allow our minds to wander and think of new problems and frame them in new ways that the policymakers maybe haven't considered yet. I hope that answers your question.
Hi, David. Thanks very much. Can you hear me?
I can.
Oh, great.
Hello.
Thanks. Just a question about actually preventing conversion of those logged forests. So, you had really good information on the diversity and how to protect things within them. But what do you think about the actual prevention of conversion? What's the main thing that could be done there?
I guess there are a couple of intersecting things. Really, the world is conservation is waiting for the day that REDD+ steps up and helps to protect forests and fund forests, and maybe that's going to happen. But of course, the carbon funding with leakage and additionality questions are plenty related to the way things have been calculated at the moment. They're on the naughty step. I didn't get to talk about it much, but I mentioned that logging, the post-logging restoration. And I think working with policymakers to make them realize that what they have there is a resource that can continue to deliver over decades is really important. So if you cut a forest and then you just leave it, you go away and you ignore it, it almost can be seen to be a wasteland through the eyes of a policymaker. Well, what can we do now with this thing that's no longer being used? Whereas if you're talking to policymakers about the great restoration that you're doing in the forests and you're enhancing the future timber yields and also delivering whatever food for local communities or forest product, then those forests, they don't seem to be wastelands, they're being used. And I think it's being careful to make policymakers aware of just what a wonderful resource these are and how it's an ongoing resource for the nation and will continue to provide kind of tax exchequer, if you will, from a policymaker's perspective. I hope that helps answer the question.
Anybody else? Okay, yeah, sorry. Thank you, Ron.
Hi, I'm Conrad. I just wondered, I noticed you mentioned a lot of things about preventative measures in terms of protecting forests from being cut down for the teak trees, or to prevent wildlife trade by reducing the amount of animals being taken. But I wonder, is that as effective as reducing demand for these things? I know online there are massive communities of people who are obsessed with getting the rarest lizard and the rarest amphibian and things, various other creatures. And I think maybe, like, is there some need for education in our communities to reduce that demand?
Connor, great question. Absolutely. I don't really work on the social side, but there is absolutely no question that we need to be working to reduce demand as well as we can. We don't seem to be doing that, though, and I do feel that we need both demand and supply side measures, basically. And that at the moment, you are right. People in Europe, people everywhere, Australia, they are demanding rare stuff. They are getting it by mail to order or whatever have you. And we are allowing these things into our countries. If their site is listed, they have to go through an opaque process for non-detriment findings about which we'll never know whether or not that was actually a sustainably caught individual. If it's not on CITES, at least in the context of Europe, you can just bring it in, just ship it in. And so we really need, I think, to be understanding what we are bringing into our nations. We need to be having a much bigger onus on the fact that if we're going to bring things into our countries, that we know that we are doing so in a way that is not a detriment to the survival of that species, which then puts the onus on us supporting exporting nations, which tend to be countries without the resource to deliver these kinds of findings.
Yeah, David, I was wondering, could I ask a question? Can you hear me?
Yes, Noel.
Yes, Noel Priest here. I'm interested in the slides you gave about indigenous and the indigenous protected areas. One of the issues that's really a bit confounded is that indigenous protected areas are often those areas that have not yet been developed. They're almost like remnant, and they're often in the harder to access places. And it puts a lot of burden, I suppose, on indigenous people and rangers and landowners and so on to conserve. Have you been able to come to terms with that in your research and social investigations about conservation?
The short answer to that is no. I mean, so Jocelyn has now gone on to work much more on the social side for her postdoc, and I deliver the kind of biodiversity conservation, deforestation lens, and then collaborate with others who think much more about the social side of things. I do agree that indigenous areas, by nature of the way society has worked in development over decades to centuries, tend to be in more remote areas. That said, that is perhaps less and less the case as we've developed our agricultural frontiers, etc., such that indigenous communities very much are at the forefront of the battle to keep forests. Of course, these are their lands, you're right. And if indigenous landholders decide that they want to do some mining, then that's their prerogative. But the data suggests that on average, there are, of course, bumps, and on average, indigenous communities want to protect some or all of their lands, and they do a pretty good job of doing so.
Very good. Any other online questions? David, I just have one quick question for you here at the end. Really enjoyed your talk. You mentioned something about challenges of detecting logging operations in the field. And are you guys, are you working on that? Are you using machine learning, artificial intelligence to try to identify that? Can you tell us a little bit more about that work?
Yeah, so what we did there actually, Bill, was use a random forest machine learning. So this is a bit before AI. We wanted to use freely available Landsat imagery. So by making that decision, we were trading off against some of the newer products which deliver much higher resolution imagery, but they're global and they're freely available, and there's no question they're going to carry on for decades to come. It turns out, though, that when we have played with some of the Sentinel stuff, that actually the Landsat works just as well. And so it is a question now from the Latin American sense of kind of allowing people to roll this out. From other areas in the world, actually there are rad alerts now, I think they're called Wageningen, have really, they have taken on some of our approaches and rolled them out in some other areas, and they've done a great job as well. So where this black hole that was degradation of tropical forests, I think the next few years is going to see us with a really rich, usable set of information for policymakers at kind of global and tropical scale.
Very good. Well, thank you, David. It's very much appreciated. And really, we've seen a lot of the sort of cutting edge techniques along with some very interesting findings there. So really, really good to hear how you're going, how you're carrying. And on behalf of everybody, thanks very much, David. Really appreciate it.
Thank you. Take care, everyone.